Welcome back to the shop. A few months ago, I noticed that the CNC router and table were not really perpendicular to each other. So I did a little bit of Googling and it said it needed to be trammed. I'm new to CNC. What tramming means, basically, is you're going to make the axis of the router, the cutting axis of the router, absolutely perpendicular to your cutting surface on your table. The first thing you do is get that straight. Then you take a surfacing bit, run a surfacing toolpath over your spoil board, and that makes that perpendicular to the router. I did a little bit more searching and found all this information that I'm giving you now. But what I want to do is point down to the description. There's a link to a video by Lindsay, Mr. V-Carve Guru, and quite the knowledgeable individual on all things CNC for the home hobbyist and small shop. And he shows in detail the process on how you tram your router to the table. I suggest that you go look at that video. I'm not going to do as in-depth as he did because he does a much better job than I do. I'm going to kind of go over the salient points and show you how I'm doing things. But I really recommend you go look at Mark Lindsay's video at some point. So let me show you how I'm going to get started with that. The first thing you got to do is to index a plate, a glass plate, that's absolutely perpendicular to the router itself. And the way you do that is you put the glass plate down on the platen for the CNC machine and use a dial indicator and move it across the glass to all four corners and get all four corners exactly the same distance from the router. In my toolbox, I had this little no-name dial indicator, and it's 1 to 100 thousandths per sweep. And most dial indicators that have a plunger that passes through it, they have a little cap that goes on this little threaded piece here. So I took that cap and I fastened a piece of aluminum to it that has a 1/4 inch borehole. It basically is a 1/4 inch tubing with I think it's a 1/2 inch outside diameter, 1/4 inch hole through it. I machined out the bottom of it so it fits that cap. I used JB Weld to glue that cap in place. So that screws right on there. And then I drilled and tapped an 832 hole for a set screw. Now I have a piece of 1/4 inch steel rod. I put it into the dial indicator, and now I can put that up inside my router, the 1/4 inch collet of my router, and now I have a good up and down measurement, very accurate up and down measurement. And I can skitter this across the glass plate and get it all shinned up correctly. Once that's done, you're going to have a bracket that takes it out away from the center of the router, but can sweep the dial indicator around and keep it on the glass. And so now you're going to measure out, in this case, about 6 inches, how tilted or as they say, what is it called? Tilted or one way or the other the router is. In Mark Lindsay's video, I learned that front to back is called nodding. So it's nodding front to back. He suggests do the nodding first, get that lined up correctly, and then do the side to side. And basically what you do is you rotate this around front to back, find the difference between one side and the other, split that in half, take a shim that goes in there to move the router front to back to eliminate that tip, and then test it again. And the suggestion is buy a set of the thin shims from an automotive shop, the metal shims, and sacrifice that to get the thickness of shims you want out. I've also got some brass thin shim stock in the shop that goes down to 5 thousandths, I think. So that's what I'm going to do now. The next thing is to make that bracket that goes out 6 inches, and I have two more pieces. I have these 2 pieces of steel 1/4 inch rod, and now what I need to do is weld a piece of flat stock between those two, so that it's rigid, and then I can sweep it around in that 6 inch circle to get the router adjusted. So let's do some welding. So here's my 2 little 1/4 inch rods for the extended bar to put it out 6 inches, and a piece of 3/4 inch by 1/4 inch 3/16, quarter-inch bar stock. I'm going to set this up on a piece of metal on the bench here. Hold it together with a rare earth magnet, and I really don't need to put full welds in this. I really just need to put a couple of spot welds on either side, or one spot weld on either side, because there's no load on this. It's just going to hold my my dial indicator. So let me show you how to set this up. So I got a piece of sheet steel here to help conduct the electricity for the welder. So place this piece of metal here and use the rare earth magnet to hold it all together here. And I'll do the same thing when I weld that piece in place. So let's burn some wire. Okay, nice and hot. I have to wait for that to cool off, and I can clean up the welds a little bit, make it look a little nicer. I wouldn't call it a design failure. I just call it a design failure on my part and a failure of imagination. Once I got the stack together and put it in the router, I find out that with the router all the way up, I can't get past the gantry support for the router motor itself. And if I crank it down to where it can get past this, I squish this thing. It just isn't going to work. So what I've done is I've got another dial indicator that has the quarter-inch hole tab on the back. I'll remove this pin here and then screw that together there. Then I can get this much. I can get about 2.5 inches lower towards the glass, and I can start tramming. So I'll end this video right here. The next video I'll have all this together and I can take you through the tramming process. Oh yeah, and I got some playing cards for shims to go under the glass. They're very consistent. They're 0.010 of an inch each. So with that, I'll see you next time, and make great things out of wood.